So I wanted to take a chance to go over the three warm-up problems for you. The first one asked you to convert a point to polar. So something to point out right away that came up on the quiz was if it says convert to polar, that means this is rectangular. So this is your X and your Y. So you really have two choices for this particular problem. You could just plot your point. So this point 0, -6 ends up, it's a quadrantal angle. So because it ends up on one of our axes, you can then just say like, okay, how would I get there? I would have to go 3 pi over 2 and 6. So you could get your point. If you land not on an axis, then you have to put the work in. So let me show you my work. You use the fact that x squared plus y squared is r squared. Plug in x and y, you find that r is 6. And then you're thinking about tangent. You use tangent because you have the x and the y. And from Sir Sixtertix, tangent is the y over the x. Now, that value is undefined, but it doesn't matter because I'm trying to think about tangent of what angle would give that undefined value. So where is the y -6 and the x 0? That's down here at 3 pi over 2. So that was number one. For number two, you were looking at converting an equation. So we had an equation here, we were converting it to rectangular. Now, if we were going the other way, that is a pretty easy direct substitution. X is our cosine theta, Y is our sine theta, and you just solve. Little trickier when you start with polar because there are different things that can happen. Sometimes you need to square. Sometimes you need to substitute. Sometimes, like this one, you want to multiply both sides by r. So you can see I did that. And why I did that is because it created this. R squared equals 7r sine of theta. Now we can use our formulas. We spent a good bit of time establishing these formulas. R squared is the same as x squared plus y squared. R sine theta is the same as y. So if you got to this step, you got it to rectangular. So that was awesome. Now we're trying to put it in standard form. So completing the square is what I worked through. So moved the 7y over. We do b over 2 and we square it. We get kind of a gross 49/4 there. We remember to add it to both sides. Now, the trick with completing the square is that you added the 49/4. When you factor it, you just use the fraction that's divided by 2. So you don't need to actually think of factors for 49/4. You just use before you squared it. That's always what goes right in your parentheses. I kept the fractions. You could do decimals if you wanted to, as long as they were exact. I prefer fractions because they're always exact. So you can see here, this is a circle. The center would be 0, 7/2, and the radius is 7/2 as well. Right? So that was the review of polar. You're working with polar as you do your project that's due on Friday. And then our third question was about parametric, and that was from last class. So we're looking for those two things, right? Can you graph it with a chart? Can you change it from parametric into regular rectangular? So the trick here, because these are trig functions, is isolating the cosine, isolating the sine before you square. So then we square both sides. Notice I didn't actually FOIL out. I left it as x minus 3 quantity squared because I'm going for something in standard form. So you don't have to worry about foiling. You leave it like that. Why did I square these? Because now when I do, technically I would say elimination solving, adding the two equations together, sine squared plus cosine squared gives 1. So you end up with this, and this could be what you have. I saw some people doing, calling that an ellipse. But then you notice 4 and 4 actually match. This is a circle. It looks like an ellipse because it's in this form. But if you multiply the 4 to get it actually truly to standard form, you can see that it's a circle with a center at 3, 1 and a radius of 2. And that's what you can see in my picture here. So that is eliminating the parameter, getting it to rectangular form. I could graph it from there. I could also graph, maybe you graphed first because that's the easier part. You make a chart, you pick your t values. Because it was in radians, I wanted to pick t's that were in radians. I probably should have also done a pi over 2. So plugging in the t's to get our exact values. By pi over 2, I meant 3 pi over 2 to keep going around there. Let me do that real quick. That would give me 3 and All right, so that's the chart that I should have made to get all of those points in there. And what this can show me, if I did it first, it gave me the fact that it was a circle. If I'm doing it afterwards, it's going to show me the direction of my arrows. So at t equals 0, I have my 0.51. So I started here. Then I go to 3, 3 and keep going around. So now I can see that my arrows are traveling around. So that was the warm-up. Hope it went okay. I hope that really that it was a good review, jogging your memory for what we've been doing.